Today we're going to talk about distributions of data. Now, oftentimes a lot of data is put into a graph so people can visually see how that data is spaced out. What we have in front of us are histograms, and if you remember, histograms basically talk about how many numbers are in certain ranges. So like in this graph right here, there's a lot of numbers in this range of values, whereas there are very few numbers in this range of values right here. So we talk about something that's negatively skewed within a histogram. If it's negatively skewed, the majority of data is going to be on the right-hand side. So once again, you can see that all the bigger numbers are on the right-hand side of this graph. If it's a symmetric distribution, you have an even spacing of numbers on each side of the middle. If I have something that's positively skewed, the majority of data is on the left-hand side of the graph. So you can see that all the big numbers are on the left mostly. It's pushed over this way. So what we want to do is we want to take and use a calculator to actually construct a histogram and use it to describe the shape of the distribution. So let's go ahead and do that. So once again, we'll go to Stat on our calculator and to Edit. And in L1, I'm going to type in all the numbers that I see up here. I've already done that, so why don't you go ahead and do it. Then, once we're done with that, we take and we're going to have to construct a histogram. So we go to our stat plot, which is right above L1. So I hit second y equals. Notice my stat plot's off. I hit 1 and I'm going to turn that on. And we've got a number of choices which I can graph. I want to graph a histogram, which is this third guy over. So make sure you cursor over to that, hit enter. We're going to take all our x values from L1. And then what we're going to do is quit this. So second quit. Now we're going to have to set up an appropriate window to look at. My numbers go basically from 2 to 27. So I think if I go from 0 to 30, I'll see all my possible x values. And then within the given ranges, there's probably no more than, I don't know, 10 in each range if I go by 3s. So let's set our window. And here's how we'll do it. I'll start at 0. Then I'll go to 30 for the x's. My scales will be by 3. So what it'll do is my bottom ranges will be for every 3 numbers, I tally how many data points are in there. And then I'm going to look at y's going from -5 all the way up to 10 so I can see the whole graph. Then I'll hit graph. So here we go with our histogram. And you'll see if I just go right along the way of this, if I hit trace, if you will, okay, that means from 0 to 3, I have 1 item. If I go to the right, I have 1 item from 3 to 6. If I move right one more time from 6 to 9, I have 2 items. Moving over from 9 to 12, I have 3 items. And on up the line, you can see how many items are in each range of 3 that I picked. From 21 to 24, there's 7, etc., etc. So you'll see, in this case, most of my data is to the right-hand side. And if we check previously, when most of the data is to the right-hand side, this is a negatively skewed distribution. When we start looking at box and whisker plots, and we look at what's called a negatively skewed distribution here, remember negatively skewed histograms was where all the data was to the right. Well, notice most of that box and whisker is over on the right side. So the left whisker is longer than the right, first of all. And the median is closer to the shorter whisker. So that's what I have right here. Remember, this represents 75% of the data, and it's moved over to the right-hand side. When it's symmetric, the 2 whiskers are about as long as each other, and the median's in the center of the data. Positively skewed means most everything is moved to the left side. 75% of our data is more on this side of the graph, and the median's closer to the shorter whisker. So now what we're going to do is use our calculator to construct a box and whisker plot, and then use that to describe the shape of the distribution. Fortunately, what I did for you is I kept the same group of data so we don't have to type new stuff into our calculator. So let's go to the calculator. So once again, we can hit Stat, Edit, and just verify everything's still there. And what we're going to have to do is change our graph a little bit. So we go back to Stat Plot, hit Enter, and we move from our histogram to a box and whisker. So we go down to the second one, move over 5 times, hit Enter, and then if we graph from here, we should get a box and whisker. Once again, hitting Trace, you can see that it gives us a median. We move over, it gives us the Q3 value. Move over, gives us the upper extreme. We move all the way over, there's a Q1, and the lower extreme or the minimum value. And we can see once again this is heavily weighted more towards the shorter whisker. So this is a negatively represented or skewed data, which we knew because we were taking the same data before. We just used our calculator to find the box and whisker. So now let's talk a little bit about how these skews affect the data. When we've got symmetric data, the mean's pretty much going to accurately reflect the center of the data. Outliers, we've talked about before, greatly affect the average. Medians are less affected, if you will, by those outliers. Skewed distributions mean that the mean gets moved from the middle a little bit more, and the median kind of stays within the middle of that data, and that's kind of represented in this case. The mean, if we think of these bars as the number of numbers in the set, gets slid over just a little bit because I have more items down in this area of the lower end, and the median is dead center middle. So keep in mind that the majority of numbers lie to the right, so the median gets shifted over to the right. In this case, the majority of numbers gets over to the left, so within the total of this graph, the median or the middle number moves over. So if we want to choose the appropriate statistics to represent a specific shape of distribution, if the distribution is symmetric, then what we typically use to describe that set of data is the mean or the standard deviation, because our mean accurately reflects the middle of the data. If the data is going to be skewed or has outliers, we typically use a box and whisker to discuss the distribution. In this problem, we have averages of bowlers for 5 teams that are shown, and we want to describe the center of the data and the spread of the data using either the mean and the standard deviation or the 5-number summary, which we just talked about as a box and whisker. We want to justify this by constructing a box and whisker plot for the data. So let's take a look at the box and whisker plot of this data first, decide if it's skewed or if it's normally symmetric, and then from there either use the standard deviation and mean or the median. So once again, we'll go to Stat, hit Edit. You'll have to plug in all these numbers. I've already done so, but go ahead and do that. It'll take you a couple of minutes. Why don't you pause? Then what we'll do is we'll make sure our stat plot is still on our box and whisker, which it is. I've moved over. From there, we're going to have to set up the appropriate window. Now, you look at your lowest score, which is about 131, and your highest score, which is about 203. So I want my x's to show that range of numbers. So let's hit Window, And I'm going to set my x's from 120 to 230 so I can see this whole box and whisker. Then I'll hit enter, and I notice that in this box and whisker we have our mean closer to the short whisker over here, so this is skewed negatively. So what we're going to do to describe this data is use our box and whisker plot and our median to describe the data. So let's take a look at our solution. Distribution skewed, so we use a 5-number summary, and remember our 5-number summary is the same as a box and whisker. Okay. The range of this data goes from 203 to 123, which is 80. The median, we can use that box and whisker and find that if we hit trace, which we'll do right here, and move over to the middle. It's already on the middle, is 176.5. And half of the bowlers on average are between 150 and 190, and we can see that by looking once again at our graph. And there's our 190, and there is our 150. And remember, this is 25% of the data in this range here, and this is 25% of the data here, so we can say 50% of the data is between these two scores. Let's take a look at another example. So we've got shoe sizes now of a group of men. We want to describe the center and the spread of the data using either the mean, standard deviation, or the quartiles and median. And again, we're going to justify this by looking at a box and whisker. So let's go ahead and do that. Once again, we'll go to that calculator, hit stat, go edit, plug those set of numbers into the list, which I've already done. We'll go to our stat plot, make sure we're on box and whisker, which we are. I need to set that window up. The window for the last problem was 120 to 230, but now our shoe sizes are going from size 9 to size 15. So I could probably look from, I don't know, 6 to, let's go, 18, and then hit graph, see what happens here. And there's our box and whisker. So in looking at this graph, I'd say this graph is more symmetric than anything else. If you can see this median right here, it looks to be right in the middle. So what I would do for this graph is I would actually use our standard deviation and our mean to describe the data. So in order to do that, I'm going to have to actually go and calculate our one variable statistics. So we'll go to our stat button once again and hit calculate our one variable statistics. And here's our standard deviation and our mean of 11.5. And we'll write this down, 11.5 for X bar and 1.8 for our standard deviation, which means the average shoe size is about 11.5 with a 1.8 standard deviation. So that information is grouped fairly tightly to our mean. And if we look at our suggested answer, since that box and whisker is more symmetric, we use that standard deviation to describe the data. And there we have it. So that's all we've got for the day. Go ahead and write your lesson summary. Here's your first question, followed by the second. Go ahead and practice on your calculator. Be ready for tomorrow because we'll do a few more of these.